All right, we're going to talk about congruence and overlapping triangles. So a lot of this is looking at triangles, maybe separating them out to see which triangles are congruent. So here's our first example. So it's identifying common parts. What common angle do a triangle ACE and triangle BCD have? So here, if I were to separate this out, okay, so ACE is essentially this triangle here, right? ACE, and then BCD is essentially this triangle, BCD. So notice they have this in common right here. So angle C is what they have in common, all right? All right, so here's our example 2. It's using common parts. So here I have two angles that are congruent. So given angle ABC, ABC, so this whole angle here is congruent to angle DCB, so this whole angle, and DBC, so this smaller angle is congruent to angle ACB, so this little piece here. Prove that AB is congruent to DC, all right? So we have our statement, we have our reasons. So the first thing I'm going to do is go angle ABC is congruent to angle DCB, and angle DBC is congruent to angle ACB. Okay, so that's given. All right, so we know that. Now, if you're having a tough time looking and seeing what they're asking you to do, pull these triangles out. So what I might do is I might look at, so I know this triangle here is A, B, C, and then we have a triangle here that is B, C, D. And when we look at this, I know that these angles here are congruent, and then these two angles are congruent. So now I have two angles that are congruent. These triangles would be congruent if I had one more common side. So if I could show that BC is congruent to BC, these triangles would be congruent. Well, the nice thing is that BC is congruent to BC because it is reflexive. Okay, so now I know these triangles are congruent. So triangle ABC is congruent to triangle DCB by the angle side angle theorem. Okay, so now these triangles are congruent by ASA. Well, since the triangles are congruent, all the parts have to be congruent. So part AB is congruent to DC because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay? So we want to make sure that we understand this. Okay? Our last one is going to be working with solving multiple parts of this. So what we're really trying to look at is solving right here. We're really trying to solve this, show that these two little pieces here are congruent, okay? So that's what we're really trying to get at, okay? We have given AB is congruent to AC, so AB is congruent to AC, and DB is congruent to EC, all right? So we have our statements, we have our reasons. So the first thing is I'm going to write down my given. All right, EC. So that is given. All right. So once I know that piece, I may try and get, so since I'm trying to get to these two sides here, I probably am trying to find this triangle here is congruent to this triangle. Okay. So I'm really trying to look at finding that congruency there. All right. So what might happen though is I might have to find these triangles first, right? So I might have to find this piece and then this piece. Okay? So if I have AB is congruent to AC, so if I have a triangle up here, and I'm going to take out all the inside pieces. Okay, so all the inside lines are out. If I know these two are congruent, what else do I know? Well, I actually know that these two angles are congruent. Now, I can't just say angle B because there's lots of angles there. So I could say angle ABC is congruent to angle ACB because of the isosceles triangle. Okay, I'm going to abbreviate iso triangle. There we go. I'll abbreviate. So now, the good thing is now if I look, I also know that this is the case, right? Let me put two dashes here. So now, if I separate this into two other triangles, so this is B, this is D, and this is C, and then I have this. So this is ECB, right? I already know that this is true, and I know that this is true. Well, okay, I have a side and angle. Can I prove that these two triangles are congruent? Well, I can because notice here, what is my bottom? My bottom is the same. So I'm going to say BC is congruent to BC, and that's the reflexive property. Okay? Okay? So now I have that these two triangles are congruent. So I'm going to write that down. Triangle DBC is congruent to triangle ECB because of side, angle, side. Side, angle, side. Well, the good thing about that is now I'm given that this angle here is congruent to angle E. So I can't just use angle D and angle E, but I'm looking at this angle here and this angle. So I know that these two angles now are congruent. Okay? So angle BDF is congruent to angle CEF because of corresponding parts of congruent triangles are congruent. Okay? So we have that. We have, so now I have this, right? So I'm going to kind of erase this inner part so we can see. I don't have that. Okay. Do I have anything else? Well, I notice here that I actually have these two angles here. Why are those two angles congruent? Well, those are vertical angles. So angle DFB is congruent to angle EFC because of vertical angles. Vertical angles are congruent. Well, now I have angle, angle, side, angle, angle, side. So now I can say triangle BFD is congruent to triangle CFE because of angle, angle, side. Well, now that I have the triangles congruent, I can now say DF is congruent to EF because of corresponding parts of congruent triangles are congruent. So just the toughest thing is being able to see what you're trying to work with these overlapping triangles. Go ahead and redraw your triangles out to give you an idea of what you're looking at. All right, so that's overlapping triangles.